Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. And the tensile forces, of which one is shown, act at the origin. One of the unknown forces has a magnitude of 240 newtons and passes through 3, negative 4, 2, while the second has a magnitude of 300 newtons and passes through negative 153 units. So determine the resultant force expressed in vector form. Since we have to express the resultant in terms of the vector form, then we must also write the compute the resultant of these two unknown forces in vector form. And the distances are components of distances are automatic these values here because the starting point of the three forces is the origin, which is 0, 0, 0. So for F1, which is this, so we have to solve F1xz first. So F1xz is 500 cosine of 40, which is this. So that would be 383 newtons. Then F1x is F1xg, which is 383. It is positive going to the right, so it is 383 cosine of 15 degrees. And that would be equal to 369.9 newtons. And we already experienced force resolution of this type. So I hope that you now follow this solution. No more drawing of the top view. Then Fy is this vertical component, F1y. So it is positive 500 sine of 40 or 500 cosine of 50 degrees because this is 50 degrees. So let's just use 500 sine of 40, and that is 321.4 newtons. Then Fz is the opposite of 15 degrees in this right triangle supposedly here. It is opposite to the positive z-axis, so it is negative. Negative 383, the hypotenuse, which is F1xz times sine of 15 degrees. So negative 383 sine of 15 degrees is negative 99.13 newtons. So that's for F1 and the components of F1. So F2, the magnitude is 240 times components of distance, namely 3i minus 4j plus 2k, all over distance, square root of 3 square plus 4 square plus 2 square. So we write it in vector form. Magnitude of the force times components of distance in vector form, 3i minus 4j plus 2k. Just copy that. Then divided by distance, square root of 3 square plus 4 square plus 2 square. So F2x is 240 times 3 divided by this distance, which is square root of 29. So 240 times 3 over square root of 29 is 133.7. F2y is 240 times negative 4 over square root of 29. And that would be negative 178.3. F2z is equal to 240 times 2 over square root of 29. That's positive 89.13 newtons. Likewise, for F3 in vector form, it is 300 times quantity negative I plus 5j plus 3k over square root of 1 square plus 5 square plus 3 square. So the x component is equal to negative 50.71. So 1 square, 5 26 plus 9 square root of 34. The distance is square root of 35. Square root of 35. So negative 50.71. F3y is 300 times 5 over square root of 35, and that is 253.5. Then F3g is 300 times 3 over square root of 35. That would be 152.1 newtons. So we can now compute the resultant. Let's add the corresponding components. So R is 369.9 plus 133.7 plus negative 50.71i, then plus 321.4 minus 178.3 plus 253.5, then plus then J, quantity plus quantity, negative 99.13 plus 89.13 plus 152.1 K. So combining, so R is 452.9 I plus 396.6 J plus 142.1 K Newton. So that's the resultant in vector form. So let's proceed to problem 10. Three forces, of which two are shown, act at a point on a particle as shown. The third missing force of magnitude 20 kilonewtons is directed from the point of application 3 units rightward, 2 units upward, and 4 units forward. So determine the magnitude of the resultant and the angle it makes with the y-axis. So let's call 28 kilonewtons as F1, 36 kilonewtons as F2. So let's solve for F1z first, which is 28 cosine of 25, F1z, F1xz, 28 cosine 25, so it is 25.38 kilonewtons. Having known F1xz, then we can solve F1x, which is also positive. It is 25.38, this hypotenuse here, times cosine of 20. So it is equal to 23.85 kilonewtons. Then Fy is this vertical component, so it is 28 sine of 25. That's Fy. 28 sine of 25 degrees is 11.83 kilonewtons. Then Fz is negative in that direction, so it is F1xz, 25.38, negative 25.38 sine of 20. So F1z is negative 25.38 sine of 20 degrees, and that is equal to negative 8.680 kilonewtons. For F2, it is 36. So let's solve for this component first. This is F2xz. F2xz is 36 cosine of 50 degrees, so it is 23.14 kilonewtons. Then the x component is opposite to 30 degrees, and it is negative in that direction, opposite to the x-axis. So it is negative 23.14, since it is opposite of 30, so sine of 30. So negative 23.14 sine of 30 degrees, and that is negative 11.57 kilonewtons. F2y is this component here, opposite to 50, so it is 36 sine of 50 positive, 36 sine of 50 degrees, so it is positive 27.58 kilonewtons. Then F2z is going forward, so it's positive. It is F2xz times adjacent of 30, so cosine of 30. So it is equal to positive 23.14 cosine of 30. So it is 20.04 kilonewtons. Then for the missing force, all the components are positive because 3 units rightward, 2 units upward, and 4 units forward. So all are positive in the positive direction. So in vector form, it is F3, 20, quantity 3i plus 2j plus 4k divided by square root of 3 square plus 2 square plus 4 square. And that would be F3x is 20 times 3 over this distance is 13, square root of 29. So 20 times 3 over square root of 29 is 11.14 kilonewtons. F3y is 20 times 2 over square root of 29, and that would be 7.428 kilonewtons. Then F3z is 20 times 4 over square root of 29, and that would be 14.86 kilonewtons. So let's now compute the resultant R in vector form first, so that from there we can compute the magnitude. So R equals 23.55 plus negative 11.57, then plus 11.14I, plus 11.83, quantity 11.83, plus 27.58, plus 7.428J, then plus quantity negative 8.68, plus 20.04, plus 14.86. So combining, we have R equals 23.42I plus 46.84, J plus 26.22 newtons. So the magnitude is square root of 23.42 square plus 46.84 square plus 26.22 square. So the magnitude is 58.57 kilonewtons. That's the answer because we are required for the magnitude of the resultant. And the angle it makes with the y-axis. So remember that RZ is 46.84 equals R cosine theta y, sorry. Ry 46.84 equals magnitude of the force 58.57 cosine of theta y. So solving for theta y is 34.11 degrees. So that's it for these two problems here. Okay, let's proceed to problem 11. The tensile force in cable AB is 26 kilonewtons and that in cable AC is 15 kilonewtons. Determine the resultant force exerted by the cables at point A. So for the solution, so let's have the figure first. Um, Take note that tension in cable AB is 26 and in AC is 15. And the distance in cable AB, so that's 26 and this is 15 kilonewtons. So distance in AB is square root of 3 square plus 4 square negative 4 square plus 12 square. So from A to C, because distance A to B is square root of 3 square, positive 3. Then going down, 26 is to the right, downward, and backward. So negative 4 square, then negative 12 square. So that's why distance AB is 13. Distance AC is square root of 3 square plus negative 4 square. So that is equal to 5 meters. So let's compute the x component of the resultant. So the x component of 26 is 26 times 3 divided by 13. Tension AB is 20 in vector form is 26. Force times component of distance. So we have 3I minus 4J minus 12K over 13. So tension AB in vector form is 6I minus 8J minus 24K kilonewtons. These are the components, the X, the Y, and the Z components. For tension AC, it is 15 magnitude times 3I minus 4J plus 0K divided by 5. So tension AC in vector form is 9I minus 12J then plus 0K or minus 0K kilonewtons. So combining like components, so 6 plus 9, so the resultant has 6 plus 9I plus negative 8 minus 12J, then plus negative 24 minus 0 or plus 0K. So therefore the resultant in vector form is 15I minus 20J minus 24K kilonewtons. And that's it. The magnitude is square root of 15 square plus 20 square plus 24 square. And problem 12, two cables are attached to the vertical pole AB to steady it. An upward force of 2 kilonewtons is applied to the pole with the effect that the resultant of the three forces acting at point A on the pole is parallel to the x-axis. So determine the tensions in the two cables and the magnitude of the resultant. So by the way, this problem is taken from the book by Ginsberg and Jenin in second edition of their mechanics book. So this is the figure. So take note that the given information is the effect is such that the resultant of the three forces acting at point A, which is here, the forces are concurrent about A, will be parallel to the x-axis. So if the resultant will be parallel to the x-axis, it means that the y component and the Z component of the forces, tension forces, or all these forces will be 0. So that means Ry is 0 and Rz is 0, and Rx is the resultant force. So for Ry is 0, the summation forces along y equals 0. So this is the y-axis. So tension AC is negative. So it is negative, or summation forces along y equals 0. So let's consider positive in that direction. So tension AC, this component of AC, which is in the direction of BC or parallel to BC, is tension AC cosine of 30, because that's 30 degrees. Then its y component is multiplied further, which is this projection here. So this is tension AC cosine of 30. Then we multiply that further by sine of 50. So tension AC cosine of 30 degrees times sine of 50. So we treat that the negative direction as positive. So the y component of tension AD will be treated negative, or it is negative because this is negative direction. Negative tension AC times cosine 30 is this component. Then the y component is this projection here, so we multiply further this uh, negative tension AC cosine 30 by sine of 50 degrees. So that's the component of tension along the y-axis. Then the component of AD along the y-axis is positive tension AD cosine of 45, because that's 45. Then set that to equal to 0. So expressing tension AD in terms of tension AC, so tension AD is 0.9382 of tension AC. Then RZ is equal to 0. So vertical summation forces along the z-axis is 0, so 2 kilonewtons. Then these components of tension would be downward, so minus. So 2, the vertical component of tension AC is simply magnitude of tension AC sine of 30, and that's negative. While the vertical component of tension AD, because that's 45, this is the vertical component going down, so that's tension AD sine of 45. So 2 minus tension AC sine of 30 minus tension AD sine of 45 is equal to 0. So substituting the value of tension AD into this equation, so we have 2 minus 0.5 tension AC, then minus 0.9382 tension AC times sine 45 degrees equals 0. So from here, we can compute now the tension in AC, which is 2 divided by quantity 0.5 plus 0.9382 sine 45, and that gives us a value of 1.719 kilonewtons. Then from this relation here, we can solve tension in AD. 0.9382 times 1.719, so that would be equal to 1.613 kilonewtons, while the x component, or the resultant, so only tension AC has x component, and that is positive because it is directed in that direction. So it is equal to tension AC cosine of 30, which is this projection. Then we multiply further, because this is the x component of tension AC, we multiply further by cosine of 50. So it is tension AC 1.719 cosine of 30. So this is this tension here. Then multiply further by cosine 50. So Rx, or R, is 1.719 cosine of 30 times cosine of 50 degrees. So R, or Rx, is equal to 0.9569 kilonewtons. So that's it. That's it, the solution. The last problem, which is problem 13, this is also taken from the book by Ginsberg and Jenin. In order to hold the television tower erect, the resultant loading exerted on end D must be 20 kilonewtons downward. So determine the tensile force in its cable required to accomplish this. So this is the given figure, and for our analysis and solution, because the resultant is directed downward with a magnitude of 20 kilonewtons, so that means the resultant is equal to Rz, and it is negative 20 kilonewtons because it is downward. So tension AD is going uh, in that direction. So negative 10 along X, going down, so it negative 85 along Z, and going in the opposite direction of the positive y-axis, so negative 30. So the idea is Rx is 0, Ry is 0, then Rz is negative 20 kilonewtons or downward. So Ry is 0 and Rz is equal to R equals 20 kilonewtons downward or negative 20 downward. So first Rx is 0, but before that, let's compute the distance. Distance AD, so since tension is going away from point D, so it is negative square root of negative 10, quantity negative 10 square plus negative 30 square plus negative 85 square. So that's distance AD. So we will not simplify the radical, so we'll just use the whole value of these squares, sum of these squares. So that's square root of 8,225 meters. Then distance dB or BD, it is going down. So along X is positive 20, so square root of 20 square. Along Y is 0, so it is on the XZ plane, so along Y is 0. Then along Z is negative 85. So square root of 20 square plus 0 square plus negative 85 square. So again, let's just compute the value inside the radical. So square root of 7625 meters. Then distance CD, which is from D to C, so X is negative 20, so square root of negative 20 square, then positive 20 square along Y, then negative 85 square. So that would be square root of 8,025 meters. So first, let's set up this equation. Rx is 0. So summation versus X is 0. So let's begin with AD. So it is magnitude of tension AD times X component of distance, which is negative 10, divided by distance square root of 8225. So magnitude of AD, X component of distance divided by distance. The X component of tension BD is positive 20. Magnitude of tension BD times X component of distance positive 20 divided by distance square root of 7625. Then plus tension magnitude of tension CD times negative 20 over square root of 8,025. Remember, the X component is magnitude of the force, X component of distance divided by distance. Since the resultant is directed towards the negative Z direction, so along Z, so that's why it is 0. Call that equation 1. Then for the Y component, so tension Ry is 0. So tension AD times negative 30 divided by square root of 8225. For BD, tension BD times 0 over square root of 7625. But anyway, that's 0. Then for CD, it is positive 20 over square root of 8,025. So tension CD times Y component of distance 20 over square root of 8,025 equals 0. Call that equation 2. Then summation forces along Z is equal to negative 20. So Z component of AD is negative 80. Tension AD times negative 85 over square root of 8225. Then plus tension BD times negative 85 over square root of 7625. Then plus tension CD times negative 85 over square root of 8,025. Then equals negative 20. Call that equation 3. So solving these three equations simultaneously or by elimination, if you don't have the high-tech calculator, but you were trained to solve simultaneous equations, three equations, three unknowns. So it is expected that you know already how to solve three equations, three unknowns. So these are the tensions. Tension AD is equal to 4.742 kilonewtons. Tension BD is equal to 9.132 kilonewtons, and tension CD is equal to 7.026 kilonewtons. So that's all for this uh, statics for beginners 2. So for those who followed my videos, wait for statics for beginners 3, and that would be on um, resultant of uh, coplanar but non-concurrent for systems, and concept on moments and couples will also be discussed in that video. So I hope that you enjoyed watching. Bye bye.